through how we do some problem solving or algebraic solving with regards to x as an index. So when we have x as an index, we have something that looks exactly like we've done here. We've got 2 to the power of x is equal to a value. Okay, and we're being asked to solve for x like you do in so many other problems. Now, for me, two different ways that we could do this. First one, as you can see here, is trial and error. Quite straightforward, but can take time and can be very time consuming if we're looking at big values and big numbers. So that's one route of doing it. I'm going to focus on route 2 because that's the way I would strongly suggest you attempt these for future reference. But as I said, we'll run through what's happening in method 1 and then we'll look at method 2 in a bit more detail. So I know that it's 2 to the power of something gives me 64. Same way as if I said 2x is equal to 64. I'd have to say 2 times what? 2 multiplied by something gives me 64, and I can work that out by doing 64 over 2 is 32, and that's fine, okay? So that was if it was 2x, but now I'm talking about 2 to the power of x, so that's a little different. So the idea in this case is that we want 2 to the power of a specific number will give me this number alone, will give me 64. So I just got to run through, I'm going to run through all of my values and see which one does that. 2 to the power of what is equal to 64, if I can find that. So I just do 2 squared, 2 cubed, 2 to the power 4, 2 to the power 5, 2 to the power 6, and you can see that we end up with 2 to the power of 6 is equal to 64. That looks exactly like what the question says. 2 to the power of 6 is equal to 64. So I can say that that number, get rid of that number there is what my x value would be. So I can then say, therefore, x is equal to 6. Nice and simple. Now, as I said, that'll work in some instances quite quickly, nice and straightforward. In vast majority of the instances that we're going to be looking at, it won't. So that's why I want you to focus on what we're going to do in method 2 over here. So what I've asked you to do is to change the 64 to an indice value. So you're going to have to practice this, and you're going to use your laws of indices that you've used or that you've practiced with in the last few days to help with this. So you can see what I've done here. I've got 64 and I've written it 3 different ways. 8 squared is 64, 4 cubed is 64, and 2 to the power of 6 is 64. They all equal to 64. But this one here at the bottom that I've put the red star beside is the one I'm interested in. The reason for that is because it has the same base number as what the problem said. I've got 2 to the power of x, and I know that it's 2 to the power of 6, so that looks very similar. So that's what I want to know and what I want to fix with. So as you've written here, I've got 2 to the power of x is equal to 2 to the power of 6. So that means that the power and the power have to be the same, as I've written here. If the base numbers are equal, then the powers have to be equal also. So if I've got 2 to the power of x is equal to 2 to the power of 8, then because the base numbers are equal, then the powers have to be equal as well. Or if I've got 4 to the power of, let's say it's 2y is equal to 4 to the power of 10, the base numbers are equal, therefore the powers have to be equal, and I can say 2y is then equal to 10, and using that I can figure out that y is equal to 5. So that's the way that we're going to attempt these. Now the examples I'm putting on the next slide are just an indication as to what you'll be expected to be able to do today after you look at this. So again, I've got another example here, this time with a fraction. 1 over 5, 1 over 5, the base numbers are the same, so then I can say that my powers are the same or equal to. Alright, so the example that I've taken here is from the textbook. I've got 4 to the power of x is equal to 8 over the square root of 2. And I want to find out what x is. And it tells me in the question, as I've got here, this is the question, okay? It tells me in the question that x is an element of the rational numbers. X is an element of the rational numbers, telling me that I should more than likely expect a fraction as my answer. I want x is equal to something, but I think it's going to look like a fraction. So I'm just going to write a over b, let's say, for example. Okay, it's going to look like some kind of fraction. So from there, this is the important part here for me. This is the bit that we need to have the work on correctly. And we're going to use what's up here to do it. So you can see, look, I've written there 2 and 4 and 8 can all be expressed in the form 2 to the power of a. So 2 to the power of something. Because I can say, as I've written here, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. So you can see I've got the same base numbers all the way along there. And that's what I want. I want to have the same base values, because I can use my rule up here then to hopefully solve. So the question that's given to me, 4 to the power of x is equal to 8 over the square root of 2. The first thing I want to do is that I want to change all of that stuff so that they're all in terms of the base being 2. So instead of 4 to the power of x, I'm going to write 2 squared to the power of x. Instead of 8, I'm going to write 2 cubed. And instead of the square root of 2, I can change that nice and simple to 2 to the power of a half, because you guys did that for me yesterday. And I've written that there. Okay, you can see that in that box. I'll get rid of some of these lines. So you can see that in the bottom left hand of the picture that I've put in on the screen. Okay, so I've done that. And then I just work at it based around what's happening with my laws of indices that you guys have practiced over the last couple of days and before the break. So you can see I've got 2 squared to the power of x. So we know that if I've got that written there, I can just multiply those powers. So that becomes 2 to the power of 2x is equal to 2 cubed over 2 to the power of a half. Now you can see what I've done there. Down here, I brought the 2 to the power of a half up above, and then it became a minus, and then I took it away, and so on. You guys know if I've got power divided by power and the base numbers are the same, I can just do 3 minus a half. So that can become 2 to the power of 2.5, or 5 over 2, or whatever you want to say. Alright? Because it's 3 minus a half gives me 2.5. Now, we look back at my red star. I look back at this rule. My base numbers are equal, so the powers are equal. Base numbers are equal, so the powers are equal. So now I can just say that 2x is equal to 2.5. And then I solve for x. X is equal to 2.5 over 2. So I'm halving 2.5. As much as that sounds a bit silly. Half of 2 is 1. Half of a half is a quarter. So it's 1 1/4. Usually we'd put it in terms of a top heavy fraction or an improper. So I've got a mixed number here and I want it in terms of a top heavy fraction. So I just change that to then 5 over 4. So that's the kind of work that's going to be expected of you. And this is the important bit. If we get everything in the same base values, like we have done in the left-hand side that I'm highlighting there, if we get all the base numbers to be the same value, then it makes our lives a lot easier later down the line. So please use that example to give these problems a go today. Thank you.